All right. I guess everybody made it through security, which is good. Okay, so my name is Leon, and I'm actually a local boy. I started my career like in the early 90s around this area, worked for government in the beginning, then quickly realized working for a government is boring, so I worked for all the other companies. And for the good past 15 years, I've been working with MDTI, where we build and operate some of the largest sites in the world, which means I get to put my hands into like code of National Geographics and Wikipedias of the world. But what it made me realize, all that means is that for the better part of the last 2 centuries, I got to fix other people's crap. Which kind of made me believe that that's what led me to this whole troubleshooting route. But I think what was the straw that broke the camel's back was the cloud. Cloud. Problem with the cloud is it brings us the whole new destroy and rebuild mentality, right? Where you can destroy any node whenever you want to, just bring up a new one, which sounds exactly like when in doubt reboot, which was very popular in the 90s, right? Is everybody familiar with the whole pets versus cattle analogy? Anybody? So pets versus cattle analogy is basically before we took care of our servers as we would of pets, right? We cared for them, we fed them, when they got sick, we nurtured them to health. With the whole cloud mentality, right, we treat them like cattle. Is one of the cows gets sick, we slaughter it and buy a new one. Problem with that is, if one of the cows gets mad cow disease, it can infect everybody else, and all of a sudden, old McDonald's is going to have no farm and a huge debt on the farm because, you know. So troubleshooting. Troubleshooting is a form of problem solving. And problem solving, in my own words, is an ability to fix things that you know absolutely nothing about. So why? Why is problem solving so important? Well, because nowadays systems become more and more complex, right? Before we ran a website that ran one CGI Perl script. Now it's a complex set of nodes, runs with a database behind it, with a load balancer, with a whole bunch of stuff in between. And because things break at the worst possible moment. Like, I don't know about you guys, but I've never had a system that broke in a time that was convenient for me. And I don't know if anybody in this room is lucky enough for their work not being immediately seen by other people, but I don't know many people like that, right? Because everything now works on a more of a platform basis where everything you do is immediately available to a client, which means every one of your mess ups is immediately available to thousands, if not millions of people, which is not great. But if I had to summarize it in one sentence, I would probably just plagiarize charity. You don't get to code whatever you want anymore. Most of your workday is done by fixing or working with somebody else's code or architecture or relying on somebody else. By the way, just so we're clear, when I mean troubleshooting, I don't mean like, oh, I have a bug, let me open this file and fix it, right? I mean, I know in ideal situation, you're sitting there in the middle of the day with a lighter in your hand and trying to figure out, well, if I change this character, it's going to solve me. I'm talking about 3 in the morning when everything is on fire. You're on fire like in a water bucket containing gasoline kind of troubleshooting, right? Everything is broken. So when things like that happen, where do you begin, right? I mean, the first step is to replicate the problem. And you think that's a common sense, right, to go replicate the problem. But you don't imagine how many times I was talking to a developer who said, hey, I fixed the problem. I was like, cool, how do you know it's fixed? I was like, well, I ran a script afterwards, it didn't work. I was like, great, did it work? Did you run it beforehand to see if it worked? He was like, well, no, but it works now. Like, well, how do I explain this to you? So the next thing you do is isolate the problem, right? Like I said, the systems are more and more complex, and if you heard Damien Sok yesterday, right, you can go down the rabbit hole really easily to figure out where the problem may be. And the next thing is fix the problem, right? Well, if it was that easy, it would be really shortest talk in the world. Because at that point, we're still faced with the problem. We know it's broken. We know where it's broken, but we still don't exactly know what the problem is and what it affects. So a lot of this time, I will be talking about the word understanding, right? We need to understand a lot of the stuff that's happening in the system. So first of all, we need to understand the problem. Right? Going back to what I was saying. So I don't know, how many times did you hear somebody say, hey, we can't support hundreds of requests a second, we get so many more visitors coming to our site, we need to scale that. Generally it's coming from like managers, executives, right? That's a lot of buzzwords of the day. Well, problem with that is, if you can't support hundreds of requests per minute, you don't need to scale better. You need to improve the performance, right? Throwing the hardware at the problem where you can easily solve it is not a proper solution. You're not solving the right problem, right? It's example with the doors, right? You don't need more doors. You just need to make sure your doors are wider to let more people in. I'll give you an example, a real example. Can anybody spot a problem? Right? I mean, that's pretty simple, right? Except that's not the problem. It's a problem, clearly. But the problem is that the performance continues to degrade, right? The jump from, if you look at actually the numbers, the performance dip was from 200 milliseconds to 400 milliseconds, which is, I mean, it sucks, but it's still manageable. But since then, it kept on growing to almost a second and continues growing. So at some point, your site is going to become completely unresponsive. So to solve initial problem is not really going to help you if you don't solve the actual problem. Right. Which brings me to the next point. You need to understand the business because, let's face it, every technical solution you're doing is supporting something in a business world. Right. This is the best quote I've ever heard from a customer of mine. And this is so true, right? Because generally business people don't care whether you run Perl 5 or Perl 6. They don't care whether you document your code. They don't even care whether your code is clean or not. All they care is if they're still making money, right? And that making money can be direct making money, it can be exposure, it can be whatever it is, right? It's something that a business metric that they care about. And technology engineers, nobody gives a crap most of the times. So the most simple thing, right? 404 on the web page, right? Page is not found. But it means different things to different people, right? So in the middle of the night, if you get called and say, oh my God, the website is down, can you fix it? What is the first thing you fix, right? What does Amazon care about the most? Sales, right? So as an example, when you go to Amazon, everybody goes to Amazon. When you go to Amazon, the related products on the homepage is responsible for like 30% of their sales. So naturally, if the homepage of Amazon goes down, that's likely to be the first thing to fix. And if the images don't load, well, screw that. We can still make some sales, right? Now, for something a little more complicated. Wall Street Journal. What's the first thing that you care about when the site is down? That's actually exactly right. It's not the content like a lot of people would say. It is the ads. They serve, I think, 32 ads on the homepage alone. I know it's awful, it's horrible. But that's the main thing they care about. So realistically, if you abstract yourself from, well, it sucks to go into a homepage of Wall Street Journal and just seeing ads. From a business perspective, if a user just go to the homepage and see only the ads and no content, that's fine. It sounds awful, but it is fine, right? And it actually goes the other way around. What does 200 mean for you, right? When everything is fine. Like Twitter, everybody uses Twitter nowadays. But Twitter recently had this whole thing where everything was fine. The site was up. Like you can type in your tweet, press send. It says, awesome, thank you for sending your tweet. And that tweet would go nowhere. Like, is everything okay? Can everybody go have a beer because nothing is broken? Right? So keep in mind that every technical decision powers some sort of a business, right? Whether it's picking a technology, whether it's prioritizing what you want to fix, whether it's anything else, right? Which brings me to the next understanding point. You got to understand the impact of the things you're trying to do, whether it's the impact of the failure or the impact of the success, right? So how many times have you touched something in the system and everything fell apart? I mean, really. And really, the problem size doesn't really matter, right? We sometimes prioritize itself by what's in our head the most glorious problem, right? I'll give you an example. I had one of those days when everything was working, right? So I'm doing like a developer's Kama Sutra, with a phone and like an RC and like a 15 terminal windows, trying to fix like a credit card system and a mailer system, like everything is broken. Like I'm really in a fire mode. And CEO of the company calls and goes, we have a huge problem. I was like, no shit. I am fully aware. And I was like, hey, I'm fixing it, leave me alone. He was like, yeah, we have a typo on our terms and conditions page. I'm like, okay. I was like, we need to drop everything and fix it. I was like, are you kidding me? I know what your business needs, right? In this particular case, I know what your business needs. I am trying to make sure you're making money, right? He's like, no, this is the priority number one, drop everything and fix it. As it turns out, he had a compliance officer sitting in his office, and that's the only thing that stopped him from getting some sort of a compliance, which would save him like millions of dollars over the next couple of months. A typo versus a broken credit card job, right? So you gotta pick your battles in some ways. Again, going back to trying to understand the business problems, but realizing that most obvious seeming problem is not necessarily the problem. Which brings to the next question, like, is there a lesser of two evils, right? Is blowing up Death Stars with thousands of people worth a chance that they're not going to blow up another planet? Depends which way you look. And sometimes breaking means fixing, right? Sometimes, especially when you're in crisis mode, breaking may provide you a short-term fix, right? So this, again, is an example that things I broke. I've been working on something, and again, performance went up, or went down rather, and all of a sudden it's got a spiky, and availability started dropping, and turning off SSL on all the sections just solved the problem, short term, right? But SSL, everybody says it's horrible, right? If it's e-commerce side, that's just horrible. So about 10% of the application will use an SSL, right? So effectively, turning off those features would disable 10% of the revenue of the visitors for ORB, which means that 90% would still get access to all the other features, right? Marketers know this concept for a while already, right? For them, 80% now is much better than 100% tomorrow, which I found it really difficult for developers like us to grasp that concept, right? We don't want to push out the broken code, right? Which one of us wants to push out a code that we know will guarantee break for 20% of the people? Like, nobody. We'd rather wait till tomorrow, fix it 100%, and then push it out. Problem is, from a marketing perspective, that means we're losing 80% of the revenue today. Right? We're getting 100% revenue tomorrow anyways, but we're losing 80% of the revenue today. So time is literally money. Like, I had a project where literally every new developer that I would onboard to the project, I would run a query to show how much money a site would lose if it was down for 10 minutes. And it was in tens of thousands of dollars. So basically, like, if you bring one page, registration page, this is how much actual money. It's not theoretical, it's not exposure. This is how much actual money they'll lose, which does scare a few people. But which means if time is money, you want to, especially when everything is broken, you want to incrementally improve the system, right? You don't have to wait for everything to be done 100%. You can put short-term fixes to solve the problem. So let's look at a classical problem. Everything was fine, right? Then there was a problem, and then everything was fine again, right? Like cut off what was done in between and all the sleepless hours, but like that's a pretty normal visualization of a problem. Except, not a lot of people think that that's an acceptable level, right? You don't have to be at norm to continue generating revenue or traffic or whatever the KPI is, right? You just have to get to that acceptable level to solve the immediate crisis, and then you continue fixing everything else, right? So in this particular case, there were 4 different fixes that went into production, right? Each one incrementally improved the state of the system until we got back to the norm, right? But after the first one, the system became usable, which was the most important part at that time. So if something breaks in the middle of the night, you put an immediate fix in, and maybe the rest you can deal with in the morning. You don't have to spend the whole night doing this. So to quickly recap what we learned so far. So understanding what's important, understanding of cause and effect, understanding of larger impact, and acceptable risk, right? All of that is important. when you troubleshoot stuff in the middle. And now let's talk about something more interesting. What not to do when you're troubleshooting things in the middle of the night when everything is broken. So first of all, I want to recap. Don't assume that you know what the problem is. Right? I don't know how to stress this enough. So Obamacare was one of the greatest failures of our decade. And I don't care what you think about the program, but technologically, it was a complete failure. Right? I mean, they spent umpteen millions of dollars to build a system that didn't work. And not only that, it didn't scale for the predetermined number of people. I can rant about it for much longer. But since that, I happen to know a few people who work on a team that took over the project after it launched on the first failure, and they were responsible for maintaining to fix it. So we're sitting over beers one day, and I was basically given the same rant. Like, how is that possible, like, that you have such a performance issues with a predetermined user set? And he's like, oh, yeah, totally, but we're already solving this problem. We just ordered a whole new Oracle rack, and I was like, oh, cool. So what was the problem? He was like, well, what do you mean? I was like, you just ordered an Oracle rack. Was the problem a database? He was like, well, it had to be. It did not have to be. It could be. Like, I feel like what you're telling me is that you've ordered a really expensive solution for a problem that you're not sure exists. Right? Could be is not a justification. Second of all, is don't whine, right? Generally, troubleshooting is more of a team effort than anything else, and nobody wants to hear people whining that time. People are frustrated as it is. Like, we all have to deal with this, right? There's so many excuses that people give, and honestly, when it's 3 in the morning and I'm have to troubleshoot something, and people give me like excuses like, oh, it's not documented, I don't know what could be broken. I'm like, actually, it is documented. It's written in code. Like, read it. Like, the other thing is like, oh, I didn't build it. That's not my problem. Like, oh, it is now. So, like, that's not a good. It is your job to make sure everything is running. So saying that you didn't build it, well, like, well, tough. You can complain about it tomorrow morning, and I think everything is fixed. Probably one of my favorite ones. It's like, oh, it passed all the tests, we pushed it to production, it worked great. I was like, well, again, nobody cares, right? It is equivalent of saying it worked on my laptop, literally, right? And I can rant about this the whole time, that tests are woefully insufficient and you got to check stuff in production. But like, clearly, even if either your test suite is incomplete or something else happened. Like, and the best one by far is, oh, everything looks right. Well, it doesn't, right? If it looked right, we wouldn't be up at 3 in the morning. But a lot, like specifically about everything that looks right, coming in from people who tend to clinch to their mistake. And whether the mistake is because they build the code themselves and they don't want to admit that their code is broken. Like, how many of you had that problem dealing with people? That somebody wrote the code and they're like, oh, it couldn't be my code. Oh, yeah. So, totally. My code works 100% of the time, all the time. Or if you're sitting there troubleshooting something and you're going down the wrong path, a lot of people are too stubborn to back up and say, no, I think I know what the problem is. I just need a little bit more time to try to get it to like full solution. That's okay to fail, even when you're troubleshooting. Just accept it, admit it, and go on with your life. On the other hand, don't give up. Don't try one thing and like, whoop, I tried nothing and nothing it didn't work. Like, come on. And I don't know about you, but there was a few people who I worked with who felt like a solution or a problem is a personal insult on their ability to do it. Whether it's because I wrote the code or whether it's because, well, I know better how to do this, like, this is not the time, like, really. And on the other side, flip side of this, don't be here. Don't assume that if you're troubleshooting it, it's all on you and you're the only one responsible, right? Ask for help. Like, There is other people. You work on the teams for a reason. Ask teammates for help. It may be somebody has a different skill set. It may be it's just a different perspective. And you were just staring at it for like a long period of time. Doesn't hurt to ask. So now let's talk about something different. Let's talk about some of the tools that would help you with troubleshooting. And I need a drink. Not a real drink, but just a glass of water. So I'm not going to talk about specific tools that you should use, but just rather a category of tools. And there are 3 of them. There is logging, there is monitoring, and there is profiling. So logging. Actually, yesterday Doug gave a really good talk here about logging. If you haven't seen it, I recommend like when it's going to be available online watching it because it's a really good talk. But in essence, logging should be actionable, it should be concise, and it should be parsed. So how many of you heard of different log levels that you should implement in your system? How many actually are doing it? How many of you are doing it in production? Don't, please. So the only thing that you should be logging in production is the errors that you can read and parse out easily. So again, I'll give you an example. So this, you don't have to read the whole thing. I'll walk through this. This is a log for a single request. And it's actually really nice, right? It's really verbose. The developer who did it did a really good job because it shows you it's queuing particular UID, it's giving you information, starting processing, then it's going through all the steps, like or further it's saying, starting this process, finishing the process, everything is successful, giving me a nice dump of API data that it's gotten back, then saying it's completed in 420 seconds, finishing, really nice data. Except, again, when I'm at 3 in the morning, I don't want to read that data. I don't care about it. All I care about is this. I care about UUID, and I care about that it failed with the error code, right? Everything else I can derive from other sources. This is the only thing that will help me troubleshoot stuff. Keep in mind that since you've been able to find information, verbosity is really, really expensive, right? People don't think about it a lot, but that request is like 2K, which is nothing, right? Multiply it by 1,000 requests a second, which is not unreasonably a high peak of traffic, right? I mean, I have systems that serve hundreds of thousands of requests a second. Well, think 1,000 requests a second. Multiplied by 60 seconds, right? And 2 web servers, which is a pretty standard setup, load balanced web servers. You're now collecting, what does it go to? 14 gig a minute, if my math is right. Something like that, a minute. So if you let it run in production for a day, multiply that by 24 times 60, that's a lot of data, right? That's a lot of data that you don't necessarily have to store. On the flip side of this, monitoring should be all-inclusive. You should monitor everything and anything. It should be business first, because really you're monitoring the health of the business, like we talked about. You're solving the business problem, so all the technical metrics and CPU metrics or whatnot are just supportive what you're trying to do. And what's more important, it should be correlatable. I don't know if that's actually a word. But you should be able to correlate your technical metrics to your business metrics and technical metrics to each other, right, to understand what the problem is. So how many of you as developers responsible for monitoring? Wow. We got to have a talk. Okay, then. So from monitoring perspective, we should monitor everything, right? I mean, from developers' perspective especially, since the systems that we write become more and more user-facing and more integrated with the systems themselves, you need to be able to understand what's happening in systems in production versus just writing tests. So why monitor, right? We have all the tests and all the logs and everything else, right? That's the mentality of a lot of people, right? We have all the test suites, we have all the logs files that we talked about. Why would we put monitors in our code? Well, things change, right? They're like I just talked about. And when things change, they change in production. They don't change on your laptop, they don't change in development environment, they change in production. And more likely than not, things that change are things that are outside of your control, right? So I'll give you an example. I had a project I was working on. It was a marketing company with about 100 million users. They send about 1 billion emails a month, about 300,000 lines of Perl, plus they have other languages. They had 5,600 metrics collected from the systems. That included all sorts of metrics across the board. And as always, it starts with a phone call, right? Customer calls us like, everything is broken, my site is down. Oh, except this time he calls and goes, revenue is down. Something is wrong. I'm like, okay. So I look at the graph because we were monitoring the revenue. And yeah, there is clearly a dip like in the revenue, right? I mean, it's not significant a dip in the picture, but 10, 15% dip in the revenue is pretty significant for a business, right? And I'm like, okay, why do you think something's wrong, right? But let's take a look, right? So we'll look at the user perceived performance, right? Maybe something was pushed, made the site slower, less people come to the site. No, performance seems pretty fine. Look at the database load because that's general performance bottleneck, and that seems to be noted as well. So at that point, I'm talking to them. I was like, well, maybe you should be doing your job better, right? Maybe you should have your salespeople go and sell. But we'll continue digging. And luckily, we had the metrics of the email balances and email deliverability. So apparently, one of the major ISPs accidentally blacklisted them. And again, I go back. They send about 1 billion of emails per month, promotional emails. So since one of the major, I forget whether it was Yahoo or whether it was Google or whoever else, so they blacklisted it. The deliverability dropped, which means less people got emails, less people clicked on the promotion, less people bought something, revenue. Yeah. Actually, I had a very similar problem with very similar symptoms where we didn't have a metric. Right? So exactly the same situation, went through all the metrics, revenue's down, everything is fine, it's just the decline rates are higher. Right? That's the only thing we could figure out, like decline rates are correct. And I'm like, I don't know. I don't know what's happening. Maybe it's getting hit like from one of those countries where they get stolen credit cards, like India is famous for that. I think Argentina is famous for that. I was like, I don't know. Decline rates are higher. The next, and we spent, must have been at least 5-6 hours just going through everything. Metrics, database, trying to find correlations, nothing. And I'm talking about 5,600 metrics. Like, I'm not talking about like we have two. The next day I'm sitting there, still haven't solved the problem. I have no idea what it is. Same customer calls and goes, oh, by the way, can you take out the American Express logo from the website? I'm like, why? He's like, oh, we're having some disputes with them, so we're not going to accept them for a few weeks. I'm like, again, that information could have been brought to my attention yesterday. But in no way would you monitor like decline rates on individual credit cards, right? Nobody's crazy enough to do it. But after that time, I sure as hell added the monitor for them. Because don't estimate correlation aspect of this, right? So if I had the business metrics like the revenue on one side and deliverability on another side, and like what else would be market initiatives, and third side, then I wouldn't be able to see, at least to measure what's happening there, right? So when I say everything else we monitor, by everything, I mean everything. I mean systems, I mean business logic, I mean code, I mean performance. Anything you can think of should be monitored and put together. Yeah, monitoring I can talk about for a while, so talk to me afterwards if you're interested in this. But now I want to move on to profiling. And profiling is basically when you know what is broken, but you still have absolutely no idea why. Right? That's all your system commands, all your profiling tools, all your tracing tools, everything else. So again, I have a lot of examples from my own life when things get broken. Some of them I break myself. But we had an issue where, again, it was horrible performance during the busy season for sites that deal with presents, like for Christmas and whatnot. And we couldn't figure out why. The only thing we could figure out from all the monitors and metrics that we had is the CPU load just skyrocketed. We had no idea why. So I had a colleague whip up a little dtrace script. How many of you here worked with dtrace before on Unix? Dtrace is wonderful, by the way. Awesome. Can't say many good things, too few good things about it. So basically, he gave me a really nice list of every URL hit and CPU used by that URL within like a minute period, which is excellent because it gives me an aggregate of all URLs. And it shows me that all the get all API calls were taking way too long. An explicit will get all events, right? If you look at it, it was a factor of magnitude, like than anything else. So clearly, it gives a good starting point to troubleshoot stuff. It actually also showed that one item was on the top 10 list and none of the other items, which is a whole different problem. But it just shows you that doing a profile and trying to figure out what's going on, you can uncover things that you never thought about before, right? And then once you uncover those things, you continue going down the rabbit hole. We have time. So let me talk through an anecdotal story. Because we all love PHP, this one is going to involve PHP and PHP developers and how well they write the code. So how many of you are familiar with cache grind types of tools? Valgrind, kgrinds, any of the profiling tools code? Excellent. Basically what it does, it gives you a really nice representation of where your code spends the most time processing. So again, had a performance issues and got something like that back, which shows me where the time was spent. So looking at it, it was unreserved.php. They took 81% of the processing time, which I was okay. And within that, so that unreserved PHP was code from header.inc. Header.inc, as you can imagine, was a header file which was called on every single page. Okay, so I can see it if something takes a long time and it's on every single page, so it starts to bring the system down. So this is what header.inc looks like. Only a few files. And I would like to walk through them just to, like I had to walk through them a couple of times just to fully understand the beauty of this piece of code. So in general, what this function does is there is a shopping cart. It's an e-commerce site. So what the function did is to make sure the inventory is checked. If the item wasn't bought from the shopping cart in X number of minutes, hours, days, whatever it be, it would clear the shopping cart, right? Basically, put the items back on the reserve menu. So what it would do, it would go to the database and select all the items from everybody's shopping cart within that time period, right? Then, for every item returned, and I can't stress that enough, it would go to the database and figure out how many items with the same ID were in an order table. That's n+1 problem. So if there's 10 items in the shopping cart, you would run 11 queries. If there's 100 items in the shopping cart, it would run 101 times. If there's 10,000 items in the shopping cart, you get the idea. I would like to remind you, this is included in header.inc. So after that, it updates the item table to set the reserve to null. I don't know why. Because the very next line, it deletes from the items table with exactly the same IDs. So now we're looking at 3n plus 1. So when you have 10 rows, it's a 31 queries. If you have 1,000 rows, it's a 3,001 queries. So after it finishes all that, it sends them an email out that says, cron has finished. And after that, that is not all. That is not all. After that, it logs it to a file synchronously saying when and that it ran successfully. Again, I would like to reiterate, it runs on every single page request. So you can find interesting things in the code when you do that. But troubleshooting is very educational, as you can see. You can uncover really, really, really beautiful gems in there. It is iterative, right? Because frankly, just going through that, I was like, oh, I found the problem. No, that's worse than I thought. It is extremely frustrating. And honestly, it's not only frustrating to troubleshoot somebody else's code, it is also frustrating to troubleshoot your own code. Because you look in the code, it was like, who could possibly write this crap? And then you do git blame, I was like, oh. Yeah. But it is rewarding, right? It is rewarding because at the end of the day, you can solve the problem in one way or another. And that's actually it for me. I'm all looking on time. I have time for questions? So, right, so the question was like about debugging in production, like when you have no choice, right? When the errors and fatal logs are not enough, is it acceptable to enable like more debugging or trace it? Right. So yes, the question is absolutely right. I mean, you're doing it intentionally, right? It's not like you're building up terabytes of log files just because you forgot to disable the flag. You're intentional going through the risk, through the performance hit, through the why am I spacing out on this word? Through the capacity aggregation, right? You're intentional going further in order to get some information. Of course, like none of this is like a rule set in stone. Every one of those rules is meant to be broken for one reason or another. And that's a great rule. If you need more debugging, so many times I went in and enabled debugging flag or edit initial login just in production, just removed them. Didn't even put them in version control. It's not the best practice, but again, in 3 in the morning, you do what's possible and then backtrace it into your development. Yeah. So business metrics, there is a couple of ways. A lot of tools exist, right? The metrics, the graphs I showed you were from Circonus. You can use either as SAS or on board, whatever it be. And basically, they accept any type of numeric or text metric that you would send. So it really doesn't care what it is. You name it, you correlate, and then you put a definition, so like tag it, wherever it be. You can send some of that to Graphite if you're using that. That's pretty popular open source one. You use Grafana on top of that to display it. There's a lot of monitor solutions out there. Datadog does some of that, although they have scaling problems. But the way you send those the information. So generally, you get those metrics from somewhere. Right? So one of the challenges, of course, is getting the business metrics, because business doesn't like sharing metrics. Like, let's be honest. Like, I had a situation where I was sitting there staring at the graph when all of a sudden I see like swarm of people just come to the site and then just drop off. And I'm like, what is happening? Like, did we miss anything? Did performance just increase just because something happened? And like, on one floor above, marketing is popping the champagne because their promotion was significantly more successful than the third, right? Which we had no idea about, right? So getting information from business people is challenging. But there is certain information that you already have, right? If you have access to the database, you can get the revenue, right? You can get visitor information. If you have access to Google Analytics, you have visitor information that you can pipe in. So you can get all of that in, and the rest is you have to work with the business, unfortunately, to collect. Now, the way you do it, there is a program called Resmon. It basically allows you, it runs like a mini daemon that you can pipe the data to. They can send it to the monitoring solution of your choice. I think it's Perl-based, so you can write a lot of modules directly to it. Yeah, and generally, like the best way of doing it is you pipe a whole bunch of queries, a whole bunch of system like requests. You organize it in what's good, what's not, and you just pipe it. Any other questions? Yes. Sure. Yeah. Yeah, yeah. Yeah, it's very great, actually. If you're interested, yeah. Absolutely. If you're interested in monitoring specifically, Monitorama is a great tool for that. But it's not enough Perl people anywhere, really. Yeah. Yeah, yeah. Yep. Cool. Thank you.